All right, so today we're going to be solving systems of equations using this new method called substitution. Just as a reminder, systems of equations are when we have more than one equations and they use the same variables. Usually we're using x and y. Big piece here, whenever we are solving systems of equations, we want our final answer to be represented as a coordinate point. We write our final answer as a coordinate point, x, y. So here in number 1, we're asked to solve this system of equations where we have y equals 2x minus 4 and y equals negative x plus 2. Now, the biggest piece in substitution is understanding what this equal sign means. So if we just look at this top equation where we have y equals 2x minus 4, I want you to imagine that this side of the equation, the y, is the new iPhone that cost $500. And then on this side of the equation, this 2x minus 4, this represents a $500 gift card to the Apple Store. The reason we can think about it like this is because this equal sign in the middle says that this thing, the iPhone for $500, that is worth $500, is valued or equal to the same amount as what's on this side, the $500 gift card. The reason this is going to be important is because this is going to be the basis for what we're doing here in substitution. So I'm going to take the second equation and rewrite it over here. Y equals negative x plus 2. Now, we started by saying that this side of the equation, y, was equal to or worth exactly the same as this side, this 2x minus 4. Because these are worth exactly the same, I can replace or substitute this y for this 2x minus 4. So I can rewrite the second equation as 2x minus 4 equals negative x plus 2. This is helpful because now we're working with an equation that only has one variable. We only have x. Now we can solve for x. We can add 4 to both sides. So we'd have 2x equals negative x plus 6. Then we could add x to both sides to get 3x equals 6. Last step, we can divide both sides by 3. Get x equals 2. So we're not quite done because we remember we need our answer to look like an xy pair, so we only have x. Now we have the number value for x. We know that x is equal to 2, so I can take either one of these equations that we started with. We'll take the top one, y equals 2x minus 4. And now we can substitute 2 in for x because we solved and found that x equals 2. So we can rewrite this equation as y equals 2 times 2 minus 4. Now we can evaluate. 2 times 2 gives us 4 minus 4. We get y equals 0. So now we have the value for x. We have the value for y. We can write our final answer as the coordinate 2, 0. Now to check your work, you could substitute into both equations, make sure that this point satisfies both equations. Now, just a quick recap of what we did. We looked at this first equation where we had y equals 2x minus 4. And we were able to substitute or replace the y in the second equation with this piece, this 2x minus 4, because we said that y and 2x minus 4 were equal. From there, we solved and found the value of our variable x. And then once we had the value for x, we were able to substitute into the other equation and solve for y. Now let's do one more example. This one is going to be a little bit more involved. So again, we have this top equation where we have a variable that's isolated or all by itself. So we have x equal to negative 3y plus 2. Now, just like we did before, I'm going to take this other equation, 4y plus 2x equals 8. And this time, I'm going to replace this x with this value, this negative 3y plus 1. So I can rewrite this equation as 4y plus 2 times negative 3y plus 1 equals 8. Now notice that we only replace the x here. We don't replace the 2. This is equal to x, not equal to 2x, so we still need to keep this 2 right here. Now we're ready to solve for the value of y, but we're going to need to use the distributive property here. So we can start solving. We can rewrite this equation as 4y. Positive 2 times negative 3y is going to give us negative 6y. And then positive 2 times positive 1 gives us a positive 2 equals 8. Next, we can combine our like terms. We have a positive 4y and a negative 6y to get negative 2y plus 2 equals 8. Now we just have a two-step equation, so we can subtract 2 from both sides. Get negative 2y equals 6. Divide both sides by negative 2 and get y equals negative 3. Now we're not done again because we need our answer. Our final answer should be a coordinate point. So we have the value for y. Now we're going to use this first equation to find the value of x. So we have that x is equal to negative 3y plus 1. We already said that y equals negative 3, so we can substitute in and rewrite this as x equals negative 3 times negative 3 plus 1. Negative 3 times negative 3 gives us positive 9 plus 1. Therefore, x equals positive 10. Now we have the value for x and we have the value for y, and we're finally ready to write our solution as a coordinate, 10, 3. Great. Now that we've solved for x and y and rewritten our coordinate point, I want you to go back into this, substitute 10 in for x, 3 in for y into both equations to make sure that this point satisfies both equations. But this really covers substitution. Make sure you have a variable isolated, substitute in to solve for one variable, then you're going to take that value to solve for your other variable, and then make sure you rewrite your final answer as an ordered pair.